Hey guys, how's it going? I hope everything is good. In this particular video lecture, we will be solving fundamental problem for 11 of chapter 2, force and vectors. In this problem, we will be determining the direction and magnitude of one of the component of the resultant force. So this lecture is almost similar to the previous lecture, but the only change is the location and the line of action of the resultant force is different. So we'll be solving following the same step as we already followed in previous lectures. So we will be determining the horizontal and vertical component of each force. So then by applying mathematics and physics, we will get the value of the magnitude of the resultant force and its direction. So in question, it mentions that the magnitude of the resultant force is acting along u-axis. Its magnitude is 80 pound. So what we need to determine, we need to determine the value of this F force and this theta. So there are different forces are given here, 1, 2, and 3 forces are already given. So another fourth force is the resultant force. So it means that we have 3 forces component and 1 resultant force. One resultant force has 3 component. So we'll be determining the component of each force, its x and y component, like the horizontal and vertical component of each force. Then we will be applying the summation of the forces, and we'll get, and for the direction we will be applying the trigonometric ratio. So we'll get the value of the f and theta. So now I'm locating the resultant force, and its value is 80 pound on this u-axis. So the Fr, I am representing the resultant force by Fr, and its value is 80 pound. So the first step is that I will be giving notation to each force. So for the notation, I will be for this 50 pound force, I will be representing it by F1. And this 90 pound, I will be representing it by F2. So we have F1, F2, and I will be keeping the unknown force as F. It is mentioned in question as F. So the resultant force is Fr. So I will be starting the determination of a rectangular component for the F1. Then I will go to the F2, then Fr, and then I will be finding the Fx and Fy to get the magnitude of F. So I will be solving for the F1. So for the F1, it is directly acting along the x-axis. So it is directly along the x-axis. So it means that it don't have any y component. So the F1x will be equal to the F1. So the F1x will be directly equal to the F1. So the F1 value is 50 pound. So this is the x component of the F1 force. How about the y component? For F1y, it will be equal to 0 because it is directly acting along the x-axis. So there is no y component for the F1 force. Now I will be solving the F2 force, like this force. For this, I will be constructing another triangle. I will be resolving its this force 90 pound into x and y component. Then after that, I will be able to solve to find the fx, f2x, and f2y by applying similar triangle technique. So for this, I will be resolving its x and y component. So the y component of this F2 force will be acting somewhere here, and the x component will be acting on this way. So this is the x component, this is the y component. So this will be the F2y, and this will be the F2x. So here you can see that we have two triangles, and remember it's the y component is acting downward and the x component is acting on the left side. So it means the both x and y component of this F2 force will be negative. So here we have this one large triangle, and the another we have this small triangle. So for the F2x and F2y, I will be applying similar triangle technique. So for the F2x, I will be applying similar triangle technique, which says that the base of large triangle, which is F2x, divided by the base of small triangle, which is 3 in this case, will be equal to the base hypotenuse of large triangle. In my case, the hypotenuse for the large triangle is equal to 90 pound and equal to the F2 force. So 90 divided by the hypotenuse of small triangle, which is 5. So what will be the sign? As we discussed earlier that it is directing on the left side, so it will be negative. So the F2x will be equal to minus 54 pound. Now I will be doing calculation for the F3, F2y, the y component of the F2 force. So I will be applying the same similar triangle technique. So the F2y, the base, the perpendicular of large triangle divided by the perpendicular of small triangle. In my case, the small triangle perpendicular value is 4, will be equal to the hypotenuse of large triangle, which is 90, divided by the hypotenuse of small triangle, which is 5. So what will be the sign? The sign will be negative because it is acting downward. So the F2y value will be equal to minus 72 pound. So we found the horizontal and vertical component values for the F2 force. Now I will be doing for the FR. So I will be finding its horizontal and vertical component. So for the FR, we have this angle 45 degree. So we have this resultant force. So we will be finding this y component and this x component. So the x component is acting on the right side and the y component is acting downward. So the x component of this FR force will be positive and the y component will be negative. So here for the FRx, the x component, the horizontal component of the resultant force. So it will be equal to the FR times of cos theta by applying trigonometric ratios. So the FRx will be equal to the FR value is 80 and cos theta value is 45. So I'll be plugging this equation in calculator. We will get the value of the FRx and it will be positive because it is acting on the right side. So its value is 56.6 pound. Now I'll be finding the vertical component of the FR force, the resultant force. It means, so I will be finding the FRy, the y component. So it will be equal to the FR times of sine theta, basic trigonometric ratio. So the FR value is 80, sine of 45. So what will be the sign? The sign will be negative because the y component is acting downward, like the x component for the acting on the right side for the resultant force, the y component will be acting downward. So that's why it will be negative. So the FRy value will be equal to minus 56.6 pound. So I will be finding the Fx and Fy for this force, unknown force, which is the unknown component of this resultant force. So for this, the x component will be acting on this side and the y component will be acting on upward. So the x and y both will be positive for the Fx and Fy for the F force. So I will be finding if it's Fx and Fy. So the x component will be like this here, and the y component will be here. So I need to find the Fy and Fx. I will be denoting here. So I need these two forces. So for this, I will be using with the help of these Fx and Fy for the each individual force. With the help of this, I'll be finding the Fx and Fy. So as we know that the Frx, like the horizontal component of the resultant force, will be equal to the horizontal component, the summation of the horizontal component of each force. So it means that Fx plus F1x plus F2x, if we add this component, the horizontal component of the individual forces, so it will be equal to this horizontal component of the resultant force. So from this, we'll get the value of the Fx. So I will be putting the value of Frx. The Frx value is 56.6 equal to Fx. I need to find the value of Fx plus the F1x value is 50 pound. Then plus the F2x value is minus 54. So I will be doing calculation shifting 50 and minus 54 to the other side. So the Fx will be equal to 60.6 pound. And now I'll be doing the same calculation for the y component. So Fry, the vertical component of the resultant force, will be equal to the summation of the vertical component of each force, individual force. So it means that Fy plus F1y plus F2y. So I will be substituting the value of FRY, which is minus 56.6, will be equal to Fy. I need to find the value of f of y plus F1y. The F1y value is 0. Then less F2y, which is minus 72. So I'll be doing calculation for the Fy. So the Fy value will be equal to 15.4 pound. So we found the horizontal and vertical component of this force, F force. So we'll be finding the magnitude. So for magnitude, I will be applying the magnitude formula. So the magnitude will be equal to the square root of Fx square less Fy square. So I will be substituting the value of Fx and Fy. So the Fx value is 60.6 square plus 15.4 square. So I'll be doing calculation, putting the values in calculator. We will get the value of the resultant force. So it will become equal to 62.5 pound. So this is the answer for the magnitude of the resultant force. The Fy, the horizontal and vertical component of the unknown F force, and we also found the value of the resultant force. So what we need to find now, we'll be finding theta. So for theta, I will be applying the trigonometric ratio. This formula, theta will be equal to tan inverse Fy divided by Fx. So I'll be putting the value of Fy and Fx. We'll get the value of the theta. So the tan inverse will be equal to Fy value is 15.4 divided by Fx, which is 60.6. So after calculation, we'll get the value of theta. So it will be become equal to 14.3 degree. So in this lecture, we found the value of the unknown component of the resultant force, its magnitude and direction. And the magnitude is this. And for direction, we apply the trigonometric ratio. So I hope you got the basic concept behind the solving of this type of question. So thanks to everyone.